Alright guys, I'm going to go ahead and make a video to demonstrate how I like to prepare my batteries for parallel charging. So I've got 10 3-cell LiPo lithium-polymer batteries here, all discharged or mostly discharged. I'm going to go ahead and set them up all in parallel. I've got my watts up power meter here. You can use other types of power meters, doesn't really matter. I've attached an XT60 male and female connector to each end of the watts up power meter. This way I can connect it in any configuration that I like to have electricity flow in either direction with all sorts of funny setups with parallel charge boards and things like that. So I recommend you do the same. If you have other types of batteries, do the same thing with maybe an XT or a JST connector like this as well, male, female. So anyway, first I make sure I've got a couple parallel charge boards sitting around. These two parallel charge boards are dumb charge boards, meaning they have no circuit protection whatsoever. They're just directly parallel connected in the circuit board and through the wiring. So first off, I'm going to go ahead and pile up my batteries. Grab my voltmeter here, my cell checker. I just start checking the batteries one by one. I'm going to arrange them in order of lowest to highest charge from left to right. So this is 3.78. Doesn't have to be perfect, I just want to get it close. This is 3.84. .5. 3.82. 3.74. The ones that are low charge are the most important. Get those in the right order. 3.82. 3.82. 3.81. 3.84. 3.75. So I forget what this one is. Let's see what this one is again. 3.75 also, but since it's smaller, I want to put the smaller one on the farthest left. So in order of voltage charge, lowest to highest voltage, if there's two that are the same, put the smallest battery on the left, on the lower side. Alright, so now I know this is my lowest charge battery. That means that when I put these things in parallel, this one is going to be getting charged by all other batteries. The battery on the far right, for instance, here, will be charging all these batteries. The battery here will be charging all these batteries. The battery here will be charging all these batteries, etc., etc., etc. But the battery receiving charge from every other battery is this guy. That's the critical battery. So I take this one. On my charge meter, or on my power meter here, it's got source and load. So the load is the one being charged. So I plug this in here. Now, from left to right, very important, starting with the next, the next lowest, or the next battery with the least amount of charge, but more than the lowest battery, I plug it in. Now watch the current here. This is important. So watch the current. Hopefully this is focused. So as I plug this guy in, you're going to see it starts to charge the other battery. There it goes, 3.3 amps. Now this battery is only 1.3 amp hours, therefore anything over 1.3 amps is not too great for it, right? It's a 1, you want to charge about 1C, maybe 2C. 1C is 1.3 amps, 2C is 2.6, and you saw that it was up to like 3.8, but look how quickly it drops. It's already down to 1.8, 1.7, etc., etc. So I'm going to go ahead and watch this and let it get down to 1.3. Meanwhile, I'm going to plug this plug into my parallel charge board. Since I've got 10 batteries, I need to have multiple charge boards too. So this guy, I'm going to plug into this charge board like so. And then the end of this, I'm going to plug into this charge board like so. I'm just paralleling everything here. The balance lead on this charge board, I'm going to plug into the balance lead on this charge board. Alright, so now I've got these two charge boards in parallel. I think you can see these. Yeah, you can. I wanted to check the camera. So these two charge boards are in parallel. When I charge this whole setup, this is extra, don't worry about that. When I charge this whole setup, I'm going to be plugging this into my charger and this into my charger. So these go to my charger, and that distributes in parallel to all other batteries when I'm done. All right, here we go. Now you see this is down to 0.8 amps, so I can go ahead and plug in the next battery. I plug this into my parallel board. This is actually an EC3 connector, but you can fit them into an XT60 connector plug, so I'm not worried about that. So go ahead and plug this in. Watch the current as I do it. It's 0.7 amps right now, and it just spiked up to 1.5. Again, since this is a 1.3 amp hour battery, I don't want to plug in another one until I'm well below 1.3. So we're already down to 1.2. So you can see that the higher charged batteries are simply charging the lower charged batteries. Notice that I'm not doing the balance leads yet. I'm doing the main leads only. All right, now I'm down to 1 amp. Let's go ahead and do the next one. Be very careful. Do not reverse polarity of these batteries, or you will have major damage to your batteries and possibly a fire if you don't catch it quickly. Very important, because you can force some of these connectors in backwards, or at least to make contact when in backwards. So this is 0.9 amps. Here we go. And there it is, 1.4 amps. So again, get it below 1.3. All right, we're down to 1.2. Notice how fast that goes. Next battery. And we're at 1.6. 1.5 amps. Waiting for it to get below 1.3. So anyway, at the start, the battery voltage ranges were roughly 3.5 volts on this lowest one to 3.85 volts, I think, on the highest one. But notice that if you just take your time, do this right, even with that big disparity, you can make it all work out. And I'm actually measuring the current going into the lowest charge battery to ensure that it's working out as I expect without causing problems. All right, we're down to 1.12 amps. Next battery. 1.327 amps is what it went up to. So we're down to 1.2 already. Next battery. 1.45. 1.37. 1.35. Notice that each time you plug in a new battery, it's not putting all of its charge into this lowest charge battery. Rather, it's charging every other battery it's plugged in parallel with too. It's just that this lowest charge battery is going to be getting the most of it. That's why I'm measuring the current only into the lowest charge battery, but keep in mind there's currents flowing between all the other batteries as well. Anything with a higher charge into anything with a lower charge. All right, 1.18 amps. So let's go ahead and do the next one. This parallel charge board is full, so let's do this one. Again, these two charge boards are in parallel, so we're at 1.15 amps. I plug this in, make sure to get the polarity correct. 1.2 amps. It spiked up just a little bit. Next battery. 1.25, same thing. Next battery. So we're down to 1.21 right now. And I plug this guy in. And it went up to 1.31. Now we're already back to 1.28. So now I've got every one of these batteries with their main leads in parallel. Now I'm going to start to parallel their balance leads. When I do actually, before I parallel the balance leads, I want to make sure that the current here is below, I don't know, maybe an amp or so. I want to get them pretty close before you plug in the balance leads. The reason being is the balance leads can't take much current. Slowly dropping at 1.17. So remember, the current is going to drop as the batteries equalize. In other words, as the higher charged batteries charge the lower charged batteries, the higher charged batteries reduce or lower in voltage, and the lower charged battery increases in voltage. So you start out with this, this large disparity, and they slowly come together in voltage. So we started out here, the voltage comes together, and we're now somewhere around here. If I let this sit long enough, they will equalize completely and become the same voltages. But I want to make sure that each cell in series, in other words, the first cell of every battery, equalizes among each other, and I want the second cell of every battery to equalize among each other, and the third cell of every battery to equalize among each other. Something else very critical: never, ever, ever, ever do this with batteries of different cell counts. So every one of these is a 3-cell battery. All right, we're down to 1.03 amps. I'm going to go ahead and start paralleling the balance leads. Now here, since I know that they're all relatively close in their voltage, I'm not going to be too picky about what order I do it in. But again, be very careful here. You see all these different balance lead ports, and you can force these stinking JST balance lead connectors in backwards, at least enough to make contact and fry something. So be very cautious. Look at these little notches here on top of this. Get the notches correct. All right, so it doesn't matter which spot you plug it in, so long as you get it in the correct cell count and in the right direction. Now notice on this side of the board, the notches are on the left. On the bottom side of the board, the notches are on the right. So I got to do it this way on the top, reverse it, and do it 180 degrees, on the bottom. So, and again, get it in the right spot. So this is a 3-cell. Okay. Next one, when I plug it in, you might see a slight change on here. Actually, that probably won't happen until you plug in the battery that's receiving the charge from all others. Anyway, we're at 0.88 amps. Let's plug this in. We got, I didn't change anything. 0.88 still. Yeah, it's because these are sharing power among the balance leads, but we're not sharing power among the one being, receiving the charge for everything else. So that's 1, 2, 3. I got 7 more to do. So let's go ahead and get this guy. So we're at 0.82 amps. Plug it in. Yeah, same thing. So we'll see what happens when I get the last thing. Again, use great caution here. Plug in the balance leads correctly. Do not reverse polarity them, or you will fry something, probably breaking the traces in your board. It'll blow the traces. I've done that once, or maybe twice, in the last several years. All right. Okay, we're down to 2 batteries remaining. There's only 1 more port left in this charge board though, so I'm going to plug the last battery into the other charge board. We're at 0.71 amps. Okay, so I got 3, 6, 7, 8, 9. So I got 1 left, and that's this guy. Now, when I plug this one in, you should see a small drop in current through the power meter because some of the current will now be diverted around the power meter and go through the balance leads instead of through the power meter. So let's see if that happens. It should just be a small change. So we got 0.67 amps. As I plug it in, very carefully with polarity here, it goes down to 0.58. So we went from about 0.61 to 0.58. So a couple, what is that? 0.58 to 0.61. You're looking at about 30 milliamps that got diverted through the balance lead and around this thing. If the disparity in voltage was much higher, you'd see a significant amount more be diverted through the balance leads. And again, if it's more than about 1 amp, you're going to blow those balance leads possibly right at the base of the battery, which means you got to cut the battery casing off and resolder that, and that's a big pain. I've had to do that before as well. So do not plug the balance leads in until you have the batteries relatively equalized, at least below 1 amp or so of current flow through the system. So let's go ahead and verify everything. I'm going to count the main leads. I should have 10. 1, 2, 3, 4, 5, 6, I miscounted this. This is actually from the balance lead. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 10th one is plugged in here to the other end of this guy, my power meter. And then I'm gonna check the balance leads. I got the 6 cell. Don't count that one. So 1, 2, 3. The 6 cell from the other balance board. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all 10 batteries are in parallel right now, and this pack is just going to sit here and equalize. It's at 0.5 amps. My chargers are being used at the moment to charge some iCAD batteries, so I'm just gonna let this sit here. But once I'm ready, I'm just gonna drop this whole bundle into one of my charge bags here. And then just slide the whole bundle inside the charge bag. Leave the power meter hooked up, it doesn't matter. And I'm going to plug the main lead here from this balance board and the parallel charge board and the balance lead from this parallel charge board into my charger. And the charger is going to see all these batteries as just one big pack. And since it's such a large pack and my charger is kind of weak, I'm just going to set the charger to its fastest charge possible, because it's not going to exceed a 1C rate for sure with the system here. And it'll probably take a few hours, maybe 2 or 3 hours to charge this whole pack, but that's a lot easier than doing this 10 individual times to charge the batteries one at a time. You know, I'm going to get all 10 done in one single charge on my charger. So that's it. I'm not going to show that part because it's pretty straightforward. You know, just plug it in. Basically, you set your charge rate to the sum of all the batteries. So you got, you know, this is 2200, 2200, 2200, 2200. You got 2200 times 1, 2, 3, 4, 5, 6, plus 1300 times 4. So 2200 times 6. You're looking at, what was that? 22, 12. 13, what is that, 13.2 amps plus the 1300 times 4. So anyway, you're looking at well over 13 amps. My charger can't do 13 amps. So like I said, I'm just going to set my charger to its max charge rate, and I'll let it go until it's done. But that's it. Now you've seen how to parallel a bunch of batteries safely. So check out my article, electricrcaircraftguy.com. I've got a nice article about parallel charging, and I'll link to that below this video. But happy charging.